Alright, the second notes 1.4, variables on both sides. So you did simplifying the distributive property, combining like terms. Now you see what happens when you got more than one x. And this always seems to be like a freak out, but don't worry about it. It's not as bad as it seems. So again, you got the title um, and variables on both sides. Make sure you write it down. So first example, I like blue today. I got 6x and 3 equals 3x and 18. So right away you look at this and this bugs you because you're not used to seeing two x's. Usually there's two variable terms on the same side, but here there's an x on one side of the equal sign and x on the other side of the equal sign. I don't like having both those things there. That's okay though. Don't worry about it. To get rid of them, it's super easy. Or to help us out, all we're going to do is cancel out one of the extra variables. I'm going to write that here so I remember. We're going to cancel out one of them. It doesn't even matter which one. We can take the one on the left, the one on the right. It does not matter. In general though, what we're going to do is we're going to try to eliminate the smallest one. So whichever one is the smallest quantity, the negative one maybe. And again, this is just like a general thing. If you don't want to eliminate the smallest one, you don't have to. So in our case here, the smallest term, or the variable term, I got a 6x's and a 3x's. The 3x is the smallest, so what I'm going to do is I'm going to get rid of it. Then how do you get rid of a 3x? Or you got to think, what's the opposite of 3x? What would cancel out a 3x? A lot of you are probably saying to like divide by 3, which is fine, but there's still an x there. So I want to know what's going to cancel out the entire 3x term. Now you're sitting there thinking about it. Here. Alright, so cancel it out. What we're going to do is we're going to subtract it. Right? That's a positive 3x. Fine, a negative 3x. We'll cancel it out. So on each side here, I'm going to basically minus 3x. I can do that. You're allowed to do that as long as you do the same thing on the other side of the equal sign. So on this side, I'm also going to minus 3x. Draw a line. Ourselves centered. Okay, on the right, the 3x and the negative 3x cancel each other out. All you have left over is a positive 18. All right, positive 18. On the left-hand side, you have 6x, a negative 3x, and a 3. Put together the like terms. 6x and negative 3x makes 3x, and then there's a plus 3 that's still hanging out. I can't put those two together, they're not the same terms. So 3x and 3 makes 18. Now I can solve this like a regular equation, minus 3 on each side. So I'm left with 3x equal to 15, and then the final step, of course, divide by 3, and I'm left with 5. X equals to 5. Variable is isolated, and it also happens to tell me the answer. We're way back up here in the beginning. Freaking out because there's x's on both sides, that's okay. Just get rid of one of them. Doesn't matter which one. If I want to check my work, make sure it's okay. If I substitute 5 in where the x is, so this turns into 6 times 5. Oh, plus 3 should be the same as 3 times 5 plus 18. I'll do this all in one. So 6 times 5 is 30 plus 3. Is that the same as 15 plus 18? And if I simplify that, that's 33. Over here, that's 33. Yay, it makes sense. It's a true statement. All right, so dealing with variables on both sides, it's not a big deal. You just get rid of one. because you're eliminating an entire term, a whole big group of stuff. The only way to get rid of a whole big group of stuff is with addition or subtraction. So to eliminate a term, an entire thing. Remember, a term is just a thing being added or subtracted, so if you want to get rid of it, you got to add or subtract. So we're going to eliminate a term with adding or subtracting. Again, if you need to pause here to keep writing this stuff down, that's fine, but I'm going to move on. I'm going to add some stuff. Weird stuff happens when you got variables on both sides, so I'm going to explain that. All right, so we'll call this example 2. Sorry. So sometimes weird stuff happens. Let's see if you can figure it out here. So let's say we have 3x minus 6, and that's equal to negative 10 plus 3x. Again, I got variables on both sides. I don't like that. I'm going to try to get rid of one. So here, to get rid of it, doesn't matter which one to get rid of. They're both 3x's, so I'm going to, let's get rid of the first one. I'm going to minus 3x on each side. So you can see maybe what's going to happen if we start doing this. On the left, 3x and negative 3x cancel out, leaving a negative 6. On the right, 3x and negative 3x cancel out, leaving a negative 10. So now we're left with the expression negative 6 equals negative 10. There's no variable. It just disappeared. And we're left with nonsensical answer. Negative 6 does not equal negative 10. If you guys are left with something where the variables just suddenly disappear and it doesn't make sense, it just means that there is no answer. There is nothing you could pick for x that will solve this equation, because this equation will never be true, because negative 6 does never ever equal negative 10. So there's no answer for that. Similarly, other stuff might happen. Call this the third example. So let's say 5x plus 10 equals 5x plus 9 plus 1. Again, I got variables on both sides. Got 5x. 5x doesn't matter. I'm going to get rid of 5x by subtracting 5x on each side. On the left, 5x and 5x cancel, leaving a 10. On the right, 5x is 5x cancel out, leaving 9 plus 1, which is also called 10. All right, 10 plus 10, or 10 equals 10, that's a true statement. True. So what does that mean? Well, it means you could pick whatever you want for x. It doesn't matter. You're always going to end up with 10 equals 10. So this one, instead of having no answer, this actually has any answer. X could be anything ever. So this one, there are an infinite number of answers. The answer is not infinity, it's just, it can be any number. It could be 1, 2, negative 5.8, 3 halves. It could be anything. Because, much like our math magic stuff, when you put it in for x, well, this x, the x on the left will always cancel out the one on the right, and you're basically left with 10 equals 10, which is true. It's like when we did the math and everybody got 2 as an answer. Doesn't matter what you pick, they were all answers. Okay, this also has another fancy name. This is called an identity. And the identity basically says that all of this stuff on the left is equal to all this stuff on the right. Whatever's on the left is exactly the same as what's on the right, and it's literally exactly the same on the left and the right. It's called an identity. So again, these are the stuff, this is what happens when you're solving with variables on both sides. And all of this. These two examples are what happens when the variable disappears. It doesn't happen very often. I spelt that wrong. It doesn't happen very often, but sometimes it does happen. And you're either left with mumbo jumbo, which means there's no answer, or you're left with a true statement, which means there's an infinite number of answers. Okay. Sometimes happens. Most of the time, it's the other stuff from the first example. So again, after this, I got 8 examples. If you missed anything, rewind it, pause it, make sure you get it all down, and go do the 8 questions.